Perfect. Let's make this immersive. We'll use a storytelling podcast format with two speakers: Dr. Leon Carter, a radiology informatics specialist, male voice; Roya Lady, a curious learner exploring how radiology informatics and AI validation work, female voice, your role. We'll structure it around Bloom's taxonomy level 4, analyzing, identifying similarities and differences. That means we'll compare and contrast radiology informatics with regular clinical informatics and AI validation with traditional image reading, so you see how and why they differ, but still connect. The Image Whisperers, Episode 1. What is radiology informatics? Dr. Carter, I've heard about radiology informatics, but I honestly don't know where to start. Is it radiology with computers or IT in hospitals? Great question, Roya. Imagine a hospital as a symphony. Every note, the scans, reports, lab results, has to stay in tune. Radiology informatics is the conductor that keeps the imaging part of that symphony in harmony. So it's not just reading X-rays? Exactly. Traditional radiology focuses on interpreting images, detecting fractures, tumors, or pneumonia. Radiology informatics, on the other hand, focuses on managing, moving, and making sense of those images and the data behind them. Comparing systems, taxonomy level 4, analyzing similarities and differences. Feature radiology informatics, general clinical informatics, comparing systems, data type, image-based DICOM, text-based, EHR notes, vitals. Radiology deals with pixels, not paragraphs. Main system, PACS, picture archiving and communication system. EMR, EHR, electronic health record. PACS stores images, EHR stores everything else: workflow focus, image capture, transfer, storage, viewing, reporting, clinical documentation, decision support. Radiology informatics ensures image availability and accuracy. Standard languages: DICOM, HL7, FHIR for imaging, for clinical data. Radiology uses DICOM as its native language. Goal: efficient, secure imaging ecosystem, broad clinical coordination. More specialized, more visual. Roy Lady, that's starting to make sense. So, radiology informatics is like the translator between the machines that create images and the humans who interpret them? Exactly, and it ensures everything flows from the CT scanner to the cloud archive to the doctor's screen without losing accuracy or patient privacy. The core systems explain. Let me walk you through a typical workflow. 1. Imaging modality. CT, MRI, or X-ray machine captures the study. 2. DICOM standard. It wraps the image with metadata, patient name, modality, study details. 3. PACS stores and routes the image. 4. RS, Radiology Information System, manages scheduling, orders, and reports. 5. Integration. PACS RIS EHR communicate via HL7 or FHIR messages. So it's like a postal service for medical images. Perfect analogy. The post office ensures your package arrives safely, on time, and to the right address. That's what informatics does for imaging. Radiology AI validation. The new frontier. I've also heard about AI validation in radiology. Is that just testing if an AI works? Partly, but it's deeper. AI validation is the process of verifying, testing, and comparing an AI model's performance against radiologist-approved ground truth data. It answers questions like, can this AI detect pneumonia on a chest X-ray as accurately as experts? Does it work on data from different hospitals or machines? Is it bias-free across ages, genders, and scanners? Comparing radiology AI validation versus traditional QA. Aspect, traditional radiology QA. Radiology AI validation similarity difference. Is it bias-free across ages? Who is evaluated? Radiologist or technician? AI algorithm. Both aim for diagnostic accuracy. Human versus machine. Evaluation method. Peer review, audit, double reading, statistical metrics, AUC, sensitivity, specificity. Both measure performance. AI adds reproducible quantitative tests. Dataset, local cases, multi-site, anonymized datasets. Both use real clinical images. AI validation requires large balance sets. Ethical legal lens. Credentialing. Regulatory FDA CE mark. Both involve oversight. AI needs extra fairness and generalization checks. Royal Lady, so it's like an exam for the AI before it's allowed to help radiologists? Exactly. Think of radiology AI validation as the final residency exam for machine intelligence, ensuring it's safe, accurate, and compliant before joining the clinical team. Why it matters. When done right, Radiology informatics and AI validation together reduce diagnostic delays, improve workflow efficiency, enable remote reading and teleradiology, strengthen data security and audit trails, support research and AI innovation. Roy Lady. So the informatics side makes the orchestra run smoothly, and AI validation makes sure no robot plays off key. Perfectly said. Informatics builds the stage. AI validation ensures the performers, human or artificial, deliver trustworthy results. Takeaway Level 4 Analysis Summary. Concept. Similar to differs from. Core purpose instead of people. Radiology informatics, clinical informatics, focuses on image data rather than text. Manage, secure, and integrate imaging workflows. Radiology AI validation. Quality assurance, evaluates machines instead of people. Verify reliability, fairness, and accuracy of AI models. Episode closing, Dr. Carter. This was enlightening. Radiology informatics isn't just IT, it's the language of medical images. And AI validation? That's how we teach the machines to speak that language responsibly. Exactly. Welcome to the intersection of medicine, data, and intelligence, where pixels become insight. Would you like me to continue this podcast series?